on this calculator here, you turn it on with the on button, right? You can click on that on button. And then, go to mode. See the mode button right here? Once you click on mode, and I need you to make sure that it is in degrees. So how do you get to degrees? You're going to use the up, down, and right, left cursor button. I have the wheel of death. Oh, tell me it isn't so. Oh. Oh. Hold that thought. Wait a minute. It's popping back up. Shh. Good heavens. Wheel of death.
It says it's March 17, 2001.
What does? Okay, whatever you do, you're not to dink with these calculators. If you dink with the calculators, you will not be able to use them again. So there's a reason why I don't usually let my sophomores use the calculators, for those reasons.
Don't you reset it?
Yes, we are going to reset them. Shh. Okay, ready. All right, so go to mode. Use your... If we can't do this without all the talking, we won't do it at all. So scroll down and to the right. You must hit enter for the degree only to be flashing. And then go back to second and quit. So if your calculator is not in degrees, you will not get the correct answers to the problems we're going to do today. So that's number one. So then let's look at your notes here. Wow. I am going to do it on the iPad, but I want this thing to go away. I don't know how to make it go away. Maybe it'll go away. All right, so let's look at your notes, law of sines. The whole entire front page here is review. So let's go ahead and look at it. Draw a line segment from each angle of the triangle to the opposite side. So let's look at angle A. Wouldn't that be the opposite side? Side A to angle A. And then for angle B, side B is the opposite side. And it's important for what we're doing today that you recognize what's the opposite side. And some of you are going, oh, that's easy. Well, there are people that don't see the opposite side. So you need to have patience. And then for C, there's the opposite side. Number two, a ratio is the comparison of two quantities by what? Addition, subtraction, multiplication, or division? Division. And then we are using the word sine today, which we've already talked about sine. You know that sine is the ratio of the opposite over the hypotenuse, right? But we're going to use the sine in a different way today. So number three, a triangle has a given acute angle, circle its sine ratio. We just talked about that. Opposite over hypotenuse. Put the calculators down, please, right now. You're supposed to be following along with your notes. And then for question 4, a right triangle has one acute angle measuring 39.6 degrees. Oh, it says a right triangle. So let's draw a right triangle. And one acute angle is 36.9 degrees. So we'll put it there. The length of the side adjacent to this angle is 4 units. Well, which is the side adjacent? Is it this side right here? Is it this side right here? What's this side? The hypotenuse. So this is the side adjacent. So that's the one that we're going to make 4 units. And the length of the side opposite this angle is 3 units. So this would be the side opposite, right? The length of the hypotenuse is 5 units. Circle the sine ratio for the 36.9 degree angle. So you circle that sine ratio. Which one is it? Which one is it? Yep, 3 over 5. All right, so that's easy. I'll review, right? So let's go to page 2. So the great thing about what we're going to talk about today, the law of sines, is we can use, and we've been using sine, cosine, and tangent, and you've learned some of their reciprocal functions as well. But you were told you can only use those in a right triangle. Well, up comes the law of sines, and then tomorrow, or actually Monday in our case, will be the law of cosines. Thank you. Where we can use that in any triangle, not just a right triangle. So as you can see here, this triangle right here is not a right triangle. But we can use the law of sines as long as we have at least one angle and the side opposite that angle. And so the law of sines is really simple. You do have to memorize this. It's not that hard though. It's sine of a particular angle over its opposite side. So if you've got sine of A, you're going to put it over side A. Sine of B over side B. Sine of C over side C. And these are the angles. Your angles are in capital letters. Your sides are in lowercase letters. And to be honest, if you wanted to put the side lengths over the sines, wouldn't that be the same thing? Can't we take the reciprocal of these? So technically I could do A over the sine of A equals B over the sine of B equals C over the sine of C. That's equivalent. As long as you keep A with A, B with B, and so forth. But this only works if I have, now let's talk about exactly what type of triangles it'll work in. If I have this angle right here, I have to have the side opposite. So let's go ahead and circle this angle and this side. Then they can give you any other two pieces. It doesn't matter. You could have this side or that angle. So if I had this side, what kind of a triangle is it? ASS, right? Bad word, right? So if I had this side, it could be ASS. If I had this side, wouldn't it still be ASS? Because the angle is not included in between the two sides. What if I had this angle right here and these two? What would that be? Is the side included in between the two angles? This side, is that included in between the two angles? No, so it'd be AAS. So law of sines only works if I have SSA or AAS. It's the only two instances it works because those are the only two instances where I have an angle and the side opposite that angle. If we don't have the side opposite the angle, then we're going to do what's called the law of cosines, which we'll do after this lesson. So number 5 says, if you know two angles on one side of a triangle, can you find all the missing measures? The answer would be no, not with the law of sines, if. And here we go. So no. I look like a kindergartner writing. This is ridiculous. I'm going to try something different. Here. Hang on. I have a plan. Let me know if my recording stops. So no, not with the law of sines. You must have the side opposite your angle. If not, you won't be able to use that law of sines. All right, so let's look at problem 1. So notice that this one is AAS, angle, angle, side. And they've given you a picture of the triangle right here. So, and they've given you the angles. If they don't give you the angle, or if they don't give you the picture and they give you just this information here, you need to draw your own triangle. And you have no idea if the triangle is a right triangle or not, if it's an obtuse or an acute at the start. Unless they give you an obtuse angle, then of course you know it was an obtuse triangle. But you're just going to draw just any old triangle. And then you always have to label angle A, opposite, side A, and so forth. So those have to maintain the truth. But your triangle might look different than your friends, than your other friends, and so forth. And that's okay. Don't get overly concerned about what your triangle looks like. So they've gone ahead and drawn the triangle for you and labeled everything in here. When they say solve the triangle, you have to find all 6 parts to that triangle. All 3 angles, all 3 sides. Now, in this particular triangle, what can we find right now, right away?
C.
Yeah, you can find angle C because you know 2 of the angles and you know the sum angle theorem for a triangle. So that's what they're walking you through here. Find and label the measure of angle C. So 180 degrees is equal to 48 plus 93 plus the measure of angle C. And so let's go ahead and use our calculator. So I'm going to go over here and we're going to take 180 and we're going to subtract 48 and 93. So 48 subtract 93. And we get 39 degrees. Right? And so we're going to put in 39 degrees here. And then question 7 says, what side is the length of AB? That's a toughie, right? What side's that? AB or C? C. So that's side C. Because here's AB, right? So here's AB. That's why C's in there. Circle the equation which can be used to solve this problem, because now we have to find the side lengths. We've got one of them. We have the 15. But now we have to find either A or C, and it really doesn't matter which you choose. It does make a difference in the sense that isn't this the only angle and side opposite that I have? You have to use that one. That has to be one of your ratios. So I'm looking for a ratio that has sine of 93 degrees over 15, or sine of B over side B. Which one of these has sine of B over side B?
The last two.
Those two. So if I did sine of B, which would be 93, so let's put in our information, 93 degrees over side B, which is 15. What do I know in respect to sine C and C? Do I know angle C?
Yeah.
So I could put 39 degrees in here, which would allow me to find side C. And what about over here? Do I know angle A? Yep, and so I could put that in there to find this. So we can use either one of these 2 equations. So either one of these 2 will work, and it doesn't matter which you choose. So we're going to go ahead and we'll find side C first. So we're going to take the sine of B, which is 93 degrees, and put it over side B. So we're using this one here. I guess it doesn't matter. They put C first, we're going to put B. I like to always put the ratio that I know fully on the left side. So sine of 93 over 15, isn't that the side opposite? Bless you. And then sine of angle C, which angle C is 39 degrees, over side C. So then from here, we can cross multiply and solve. We can't get to number 10 yet until we do some legwork. So let's cross multiply these 2 because it's a proportion. So if I cross multiply these 2, I have C times the sine of 93 degrees equals 15 times the sine of 39 degrees. How do I solve for C? How do I solve for C? What's happening between C and sine of 93 degrees? Multiplying. So how do you undo that? Division. So we're going to divide this side by sine of 93 degrees and divide this side by sine of 93 degrees. So those cancel. And so now we're up to what they have here. And so we can place it in there. So you can see that we have 15 times the sine of 39, all divided by the sine of 93. And so 15 times the sine of 39 degrees divided by the sine of 93 degrees. And here's how I would suggest you do this on your calculator. You need to be careful with some of these more complicated ratios here. So let's go to your calculator. Let's clear this out. And then we're going to start with our numerator, 15 times, and honestly don't have to hit the times button, on these calculators. You can just put sine because it automatically assumes you're multiplying by 39 degrees. Get in the habit, please, of closing those parentheses. And then I want you to hit enter. Do not hit divided by. I want you to hit enter. So find the numerator first, and then we're going to divide by your denominator, which is, in this case, sine of 93. And then close those parentheses. And now hit enter. Did you get the same thing as I did? And what is it that we just found? A side length. Does that seem reasonable, side length, for what's already there on the triangle? Yes. And so we're going to round that to, they didn't say, oh, nearest tenth. So what is that rounded to the nearest tenth?
Miss Ray?
Yes.
The 3 was second.
Did not get it. So let me see your calculator. That's because your modes are still in radians. You didn't follow directions.
No, it is. It
No.
is. Said it was in degrees.
No,
It's in
hers was not in degrees. Let me see it.
Oh, no, it's because we looked at the wrong thing. We looked, like, see how it says radians?
Yeah, you have to, if you didn't get this, then go back into your, if you didn't get this, go
Wait, so
back
how do you
into
know?
mode. Go back into mode. See how degrees has to be highlighted? Right? So go back to your mode. If you didn't get, are we all good? If you didn't get it, you've got to ask because you have to know how to use these calculators. So are we all good? You good? Go back and recalculate and make sure you get the right answer. And so now we're back here. Make sure that you get that. So what is that to the nearest tenth? 9.10. Tenth is 10. 10 has 1 0, doesn't it? So that's 1 decimal place. So 9 point, what does this 5 do? Bumps it up to 5. So 9.5. And so that's, oh, good thing we chose C because apparently they only wanted us to find that one on this one. And then from there we could go ahead and find angle A. They didn't ask for it, so we're not going to find it. Can I use Pythagoras' theorem to find angle A in this triangle? Yes or no? Is it a right triangle? No, so I cannot use Pythagoras' theorem, but I could use this right here then to find angle A. And I would make sure that I use sine of B over side B because that was given to me. I don't want to use sine of C over side C because what if I made a mistake when I found side C? So always use what they've given you. So let's go to problem 2. Now this time we're going to use SSA. And they've given you the picture of the triangle. Again, if they didn't, you just draw any old triangle, label it KLM, and then put in these pieces. Now they've given you LM and KM. Those are side lengths. Remember, you named line segments with 2 letters. And then they've given you 1 angle measure. So we do know that it is an obtuse triangle, and I do have the side opposite that. So this right here is going to be one of my ratios. So we're going to use the sine of 105 degrees divided by 14 equals. And what side do they want? Well, they want the measure of angle K. Do I have the side opposite angle K?
Yeah.
Yeah. So we're going to set up sine of K over side K. So sine of angle K over, is that a 9 or a 19?
We can't see.
Oh, what happened to it? Hilarious. Did it just go away? That was weird. Did it just disappear?
Yes.
Okay. Hold that thought. Hold that thought. Come on. Jeepers. Seriously? Oh, there it is. Let's see. Did I lose my play? Oh, yeah. Now is it showing up? Perfect. I must have hit. That's what happens when I lay my hand on there. All right. So does everybody see that now? Yeah. Okay. All right. So that's what we're going to set up.
Is it recording?
Yeah, it's still recording. It's recording on the screen on my computer. Okay. So then let's go ahead and move to the next screen. Whoops. I didn't want that. So let's move to the next screen. All right. So up here they've walked you through it. So we have sine of what? Because I don't have my paper. 105 over what? 14 equals sine of C, angle C over, oh, is it K?
Yeah.
Thank you. Sine of K over what? 9. Okay, so we're going to cross multiply to solve for that, right? So we've got 14 times the sine of K equals 9 times the sine of 105. And then how do you solve for, we're going to solve for sine of K. We want to get the sine of K right here by itself. What's happening with it in 14? Yep, so we need to divide both sides by 14. 14's cancel. And then we get sine of K is equal to all of this. 9 sine of 105, all divided by 14. How do you break apart, remember how we did this? How do you break apart the sine on that K? If you don't know the angle, how do we find it? Yeah, remember the inverse sine, right? Sine to the -1, it's not really sine to the -1, so quit calling it that, but it's inverse sine, right? And so to find the measure of angle K, it's going to equal the inverse sine of all of this. Now you have to be careful, and I would not be putting this entire, I'm going to show you a trick on your calculator. I would not put this entire thing in the inverse sine. So we're going to find this ratio first on the calculator, and then I will show you how to input that into the inverse sine. So are you ready? So let's go ahead and go over here to the calculator. So we're going to clear this out. And you're going to start with this ratio right here. So you're going to take 9 times the sine of 105. And those parentheses, and hit enter, please. So that's the numerator. Did we all get that? 8.69. Yes? Wave your hand madly if you didn't, so we can fix it. Bring it up here quickly. Oh, okay. We're good. Okay. So then we're going to divide by the denominator here of 14. And then hit enter. So that's the ratio of 9 times the sine of 105 divided by 14. In order to get this ratio into the inverse sine, which is what we want, this is how you do it. So now hit second sine, so you have that inverse sine showing up, and it automatically gives you a parentheses. And then to get this in here, a neat little trick, look at what's above the negative sign here. What do you see? Blue, ANS, that means answer. So what you're going to do to get to that, because it's blue, you're going to hit second function, and you're going to hit the negative sign, and it immediately puts this previous answer right in there. Hit the ending parentheses and hit enter. What was it that we were trying to find? Angle K. Does that seem a reasonable value for an angle?
Yeah.
All right, and so if we're going to round to the nearest, what did they say? Did they say 10th or nearest angle? Okay, so what is that to the nearest 10th?
The answer I couldn't see.
Second negative. Second negative. Oh, I'm sorry. I thought I had it on key press history. There we go. Look at all that. It's a thing of beauty.
Wait, so then it's like supposed to be like that?
No, you didn't put it. You didn't do it right. Let's see.
Oh, it's
So we're going to clear. Oh, so we're going to do second sine, second negative,
Yeah. Oh, okay.
and then hit yours. Did anybody not get that second negative? Yes, no? Everybody get it? Okay. So then over here, we're going to put in, where'd my stylus go? We're going to put in, therefore, the measure of, oh, and this part right here, just for your own, if you go back home to try to do this, this was 0.62 0.95 dot dot dot. Just so that you have a reference. If you go home, you try to use your calculator at home, and you want to see what that ratio was. That's what we put into the inverse sine, and we got 38 point what? 38.4 degrees. And so that's all that they were asking for was K. Could we find the rest of the triangle from there? Yeah, we could, but they didn't ask for it. So then let's look at the last problem, 3. Using the law of sines to solve a problem, the right fielder fields a softball and will either throw it to first base or second base. If the right fielder throws the ball to second base, how far does she throw the ball? So they want to know this value here. Shh. So they've given us, do I have any angle with a side opposite? No, but I can find it. Why?
Because they all have
Very good. So let's walk our way through the problem. So what he just said was, currently I don't see an angle and the side opposite, right? Because I have the 45-degree angle but no side opposite. I have the 68-degree angle but no side opposite. But the fact is we know two angles, right? We can find that third angle, which is across from the 60 feet. So that's what we're going to end up doing. So in this problem, the solution is a what? What are they looking for? A side or an angle?
side.
A side. And so to find the solution, I first need to find a missing, I must find the missing angle first, right? Isn't that what we just decided? And so in order to use the law of sines, what information will you need that's missing? You need the side opposite, or I'm sorry, not the side. You need the angle opposite 60 feet. And so circle the equation we could use once we find that. Well, let's go ahead and find our missing angle. What's our missing angle? Yeah, so if you go over here, clear this out. We've got 180 minus, and you can use parentheses here if you want to subtract the sum of those angles, 68 and 40. So much slower when I have to click on my computer. And then hit enter. So we do get the 72, so that's where their 72 came from. So let's write that in there. So here's 72. And so which of these following can we use if we're trying to find the side opposite the 40 degrees? Is this the right ratio for 72 degrees and the side opposite? Is that the correct ratio? Yes, so this is correct, this is correct. What about this one? That one's not, so let's cancel that one out. So we're looking between these two. I want to find the side opposite 40 degrees. So which of these is it? This one right here. So this is the one we're going to use. And so we're going to go ahead and solve it. So we're just going to cross multiply, and I'm going to ignore what they have over here for right now. So we've got C times sine of 72 degrees equals 60. That's a terrible equal sign. Equals 60 times the sine of 40. How do we solve for C? Divide by sine of 72. And so C is going to be equal to, I would, by the way, not suggest doing it the way they're suggesting it. Because you don't want to ever round in the middle of your problem. You're going to get not as accurate of an answer. So C is going to equal this ratio here. So let's go ahead and figure out what that is. And so we have, let me clear this out. So take the numerator first. So 60 times the sine of 40 degrees. Enter. I would always do the numerator separately than the denominator. And then divided by sine of 72. Enter. How'd we do? Does that seem a reasonable distance? Yep. And so C, and I'm going to change this to squiggly equals. Why?
Because it's approximate.
Yeah, it's an approximation. And so we got 40 point nearest tenth. 40 point what?
6.
40 point, bless you, 6. And it's in what? Chicken livers, fuzzy navels?
Yeah, it's chicken.
Right. What is it
Chicken
in?
heads.
Feet. So Kimmy throws the ball about, yeah, so you always want to answer a word problem with a sentence, so 40.6 feet. And then the last page. I'm just going to quickly go through some of these. We're going to skip question 20. What about 21? Let's just talk our way through 21. If you know the three side lengths of a triangle, can you use the law of sines to find the missing side measures? Oh, it disappeared again? Oh, gracious. I don't think I touched anything that time. I think I'm just losing my Wi-Fi. There we go. Thank you. All right, so if I know only the three side lengths of a triangle, can I use the law of sines?
No.
No. Why?
Because you
Shh. Ladies and Brody. You're welcome. You're welcome. Why can I not use the law of sines in the situation that they're giving you in number 21? You have to have an angle opposite the side. So the answer is no. You must. Good gracious. No. You must have an angle opposite a side length. And then I like this error analysis question. I guess the calculator wanted to come forward. It says your friend uses the law of sines to write the following proportion. And you can see the picture right here. Did he write a correct proportion? He's got sine of 75 over 3. Is 75 across from 3? No. So he did not use the angle and the side opposite. So please write here what he should have written for the ratio. What should have been over sine of 75 degrees? 4. And then equals sine of what? Yeah, but instead of x, what should they have written? Sine of p degrees over 3. And we're not going to solve that. So any questions on law of sines? It's the easier out of the two laws, but you're still going to run against some issues. So bear that in mind.